All right, guys. This is the video for day 3. It's using the distributed property. Hopefully, it won't be too bad on y'all. It's something we've done quite a bit of. It's really helpful on problems like number 2 in the guided practice, things that you just can't add together. That's pretty much the only way to simplify those expressions. Make sure when you're doing your work, like if I'm doing this guided practice and I'm having troubles with how to do these 3, it gives me examples, like on examples on 1 through 6. Or it gives me number 4. It tells me to look at example 7. So if I'm having troubles with that, I can look up here at number 7, and I can see what they want me to do. It also works on your independent practice. It tells me here, look at example 1, for help with these problems. It tells me to look at examples 2 through 6 with these problems here. So let's get into it. Let's get it done. So that if you're having troubles, you can finish and go on and do something else today. So number 1 is 8 plus 11 times negative 3. Okay, now I could solve this problem without using the distributed property normally if I wanted to. I just say 8 plus 11 is 19, and then 19 times negative 3. So I'll write that over here. 19 times negative 3. 3 times 9 is 27. So I have negative 57. Okay, if I wanted to work that using the distributive property, I'd go 8 plus 11 times negative 3. Okay, so 3 times 8 is 24. 3 times 11 is 33. Both those answers are negative because I multiplied by negative 3. So if I add 24 and 33, I get negative 57. Okay. If I go on to number 2, I have negative 5 times 2x plus 4y. Okay, so I'm going to take negative 5 times 2. It's going to be negative 10x plus negative 5 times 4 is 20. So negative 20y. Okay, and I'm going to put that in parentheses because I'm adding a negative. So I'd say plus 20. Or you could say negative 10x minus 20y. It's the same thing to add a negative as it is to subtract a positive number. So either one of these would be okay answers. You could write your answer either way. On number 3, it's the same type of problem. Take a 1/5 g, or 1/5 times g minus 10. So I can take 1/5 times g, that's 1/5 g. Okay, and then I need to multiply 1/5 times 10, so I can come over here and do that. 1/5 times 10, I can put 10 over 1. 1 times 10 is 10. 5 times 1 is 5. So I can take 5 into 10, and that's going to go in there 2 times. So I'm going to have minus 2. I have 1/5 g minus 2. Okay? Put a line there in case you're looking back at that positive. This is where we worked one part of the problem. This is where we worked the 1/5 times g right there. Okay, number 4. It says a housefly can fly about 6.4 feet per second. At this rate, how far can it fly in 25 seconds? And it wants me to justify my answer. So I'm going to take 6.4 times 25. I'll take 5 times 4. That is 20. 5 times 6 is 30 plus 2 makes 32. And we'll put a 0. 2 times 4 is 8. 2 times 6 is 12. Now I'm going to add that stuff up. So I have 1,600. Okay. So, and I have a 1 decimal here, so I need to put 1 decimal here. So that means that it can go about 160 feet. Okay, now it wants me to justify that using distributed property. If I was wanting to know how many feet this thing went in 25 seconds, if I was taking the TCAP, this is the preferred method. If I just wanted to do exactly what the book told me to do, and I would be happy if you put this down for your answer. But if I did want to justify it using the distributed property, I would say 25. What it tells me in example 7 to do is just to round one of these, like 6.4. I could round that up to 7. And then subtract the 0.6 feet that that I rounded this up to, and so I would say 25 times 7. So 2 times 7 is 14, 15, 16, 70. So I got 175. And then I would subtract this 0.6 times 25. So I have 25 times 0.6. So I'd take 15 from it. and I'd get 160 that way. So this would be the correct way to write it the way that they want you to. But for me as your teacher, this is a fine answer. This is a fine way to do this problem. You don't necessarily have to do this right here. I do want to see that you can get the 160 feet though. Finally, on number 5, let's look at number 5. It says describe how the formula to find the perimeter of a rectangle is an application of the distributive property. So if I'm finding a rectangle, okay, this side here is going to have a length. Say this side's 5, and this side's 5, and this side's 2, and this side's 2, and I just made those numbers up. Your rectangle can be anything that you want, but generally on a rectangle, these two numbers are different than these two numbers. They don't have to be. A square is technically a rectangle, but if I wanted to add this up, I could instead of adding 5 plus 2 plus 5 plus 2, I could take 2 times 5, and I could take 2 times 2. And that would give me the same answer. Or I could add 5 plus 2 and then multiply that by 2. So I would write that like this. If I was doing this one, if you wanted to do this algebraically, I could have x plus y, okay, times 2, which would be great. And then if I was drawing my rectangle like that, one side would be x and the other side would be y. So this will be a great answer for number 5. Okay, and that's just one of those. It doesn't have an example with it because it just wants to see what you know or what you think of from those questions. Make sure you do your best on questions like number 5 and number 4, and I really expect you to do a good job on 1, 2, and 3. All right, guys, be safe, and I will see you when we get back.